Vibration and humming in an 800 amp Cutler-Hammer molded case switch can stem from several potential causes. Firstly, inadequate tightening of connections is a common culprit. Loose connections can induce vibrations and humming due to arcing. Thoroughly ensure that all bolts and terminals are properly tightened to specification. Secondly, resonance within the switch enclosure might be occurring. The enclosure could be resonating with the 60 Hz frequency of the power system, and this phenomenon can be amplified by the electrical load and existing harmonics. Thirdly, magnetic field interaction is another possibility. The magnetic field generated by the current flowing through the switch can interact with the metal enclosure, thereby causing vibrations. Fourthly, faulty contacts can be the source. Misaligned or worn contacts can create arcing and vibration. Fifthly, overload should be considered. If the switch is overloaded, it can generate excessive heat and vibration, so it is important to ensure that the load remains within the rated capacity of the switch. Here are some troubleshooting steps to systematically address the issue. 1. Tighten all connections. Meticulously check and tighten all connections, paying special attention to those located within the switch enclosure itself. 2. Dampen the enclosure. Apply vibration dampening material or gaskets to the enclosure surfaces to reduce resonance. 3. Reduce harmonics. If feasible, mitigate the sources of harmonics present within the electrical system. Doing so will reduce the magnetic field interaction. Harmonic filters might be needed. 4. Inspect the contacts. Carefully open the switch and thoroughly inspect the contacts for any signs of misalignment, wear, or damage. Replace them if necessary. 5. Verify the load. Confirm that the electrical load remains within the rated capacity of the switch. Use a clamp meter to check the current on each phase. 6. Contact the vendor. If the preceding troubleshooting steps do not successfully resolve the issue, contact the vendor directly for further technical assistance. Remember to prioritize safety when working with electrical equipment. Always to energize the circuit before performing any inspection or maintenance. Ensure proper personal protective equipment is utilized, including safety glasses, gloves, and appropriate clothing. Double-check the tightness of connections, as this is often the simplest and most effective solution. Use a calibrated torque wrench to ensure connections are tightened to the manufacturer's specified torque values. Vibration analysis, while already performed, might need to be repeated with more sensitive equipment or at different locations on the switch enclosure to pinpoint the source of the vibration. Resonance can be tricky to deal with. Changing the mounting of the switch or adding mass to the enclosure could shift the resonant frequency. However, this should be done with careful consideration to avoid introducing new problems. Harmonics are a common issue in data centers due to the proliferation of nonlinear loads such as servers and uninterruptible power supplies. Harmonic filters or reactors can be installed to reduce harmonic distortion. It is important to select the appropriate filter type and size for the specific harmonic profile of the electrical system. Regular maintenance of electrical equipment is crucial for preventing problems such as vibration and humming. This includes periodic inspection, cleaning, and tightening of connections. Infrared thermography can be used to identify hot spots, which can indicate loose connections or overloaded components. Power quality monitoring can help detect harmonic distortion and other power quality issues. Consider using a portable power quality analyzer to monitor voltage, current, harmonics, and other parameters. Compare the measured values to the equipment's rated values to identify any potential problems. If the vibration is accompanied by unusual smells or noises, such as buzzing or crackling, this could indicate a more serious problem, such as insulation breakdown or arcing. In such cases, it is important to immediately energize the circuit and contact a qualified electrician. Document all troubleshooting steps and findings to help track progress and identify any recurring problems. Keep a log of all maintenance activities, including dates, descriptions of work performed, and any parts replaced. When replacing components, use only genuine parts from the manufacturer or authorized distributors. Using inferior or non-approved parts can compromise the safety and performance of the equipment. Ensure that all electrical work is performed by qualified personnel who are familiar with the relevant codes and standards. The National Electrical Code, or NEC, provides detailed requirements for the installation and maintenance of electrical equipment. Consult the NEC for specific requirements related to switchgear and motor control centers. If the switch is part of a larger motor control center, inspect the other components of the MCC for any signs of vibration or other problems. Loose connections, damaged components, or improper grounding can all contribute to vibration. Check the grounding system to ensure that it is properly installed and maintained. A poor grounding system can increase the risk of electrical noise and harmonics. Consider using shielded cables and connectors to reduce electromagnetic interference, or EMI, which can also contribute to vibration. EMI can be generated by nearby equipment or power lines. If the switch is located in a noisy environment, consider using vibration isolation mounts to reduce the transmission of vibration from the surrounding structure. Vibration isolation mounts can help to isolate the switch from external sources of vibration. Ensure that the switch is properly supported and aligned. Misalignment can cause excessive stress on the components and lead to vibration. Check the switch for any signs of physical damage, such as cracks, dents, or corrosion. Physical damage can weaken the structure and make it more susceptible to vibration. If the switch is equipped with any moving parts, such as relays or contactors, inspect them for wear and tear. Worn or damaged moving parts can cause vibration. Consider using a surge protector to protect the switch from voltage transients. Voltage transients can damage sensitive electronic components and lead to premature failure. Ensure that the switch is properly ventilated to prevent overheating. Overheating can cause components to expand and contract, which can lead to vibration. If the switch is located in a humid environment, consider using a dehumidifier to reduce the risk of corrosion. Corrosion can weaken the structure and make it more susceptible to vibration. Check the switch for any signs of water damage. Water damage can cause corrosion and electrical problems. If the switch is located in an area prone to flooding, consider installing flood protection measures. Ensure that the switch is properly labeled and identified. Proper labeling can help to prevent accidental contact with live parts. Check the switch for any signs of tampering. Tampering can compromise the safety and security of the equipment. If the switch is located in a public area, consider installing security cameras to deter vandalism and theft. Ensure that the switch is properly grounded to protect against electrical shock. A proper grounding system can help to prevent electrical shock in the event of a fault. Check the switch for any signs of pests, such as rodents or insects. Pests can damage wiring and other components. If the switch is located in an area prone to earthquakes, consider using seismic bracing to protect it from damage. Seismic bracing can help to prevent the switch from falling over or being damaged during an earthquake. Ensure that the switch is properly maintained to extend its lifespan. Regular maintenance can help to prevent problems and extend the lifespan of the equipment. Consider using a predictive maintenance program to identify potential problems before they occur. Predictive maintenance can help to prevent costly downtime and repairs. Keep a record of all maintenance activities, including dates, descriptions of work performed, and any parts replaced. A maintenance log can help to track the history of the equipment and identify any recurring problems. If the vibration persists despite these efforts, consult with a qualified electrical engineer to perform a more detailed analysis of the problem. A qualified electrical engineer can help to identify the root cause of the vibration and recommend appropriate solutions. Remember to prioritize safety at all times when working with electrical equipment. Always energize the circuit before performing any inspection or maintenance. If the harmonic distortion is excessive, consider installing harmonic filters to reduce the distortion. Harmonic filters can improve the efficiency and reliability of the electrical system. If the vibration is caused by resonance, consider changing the mounting configuration of the switch. Changing the mounting configuration can shift the resonant frequency and reduce the vibration. If the vibration is caused by loose connections, consider using a thread locking compound to prevent the connections from loosening again. A thread locking compound can help to keep the connections tight and prevent vibration. If the vibration is caused by worn or damaged components, consider replacing the components with new ones. Replacing worn or damaged components can restore the equipment to its original condition. If the vibration is caused by an overload, consider reducing the load on the switch. Reducing the load can prevent overheating and vibration. If the vibration is caused by a combination of factors, consider addressing all of the factors simultaneously. Addressing all of the factors simultaneously can provide the most effective solution. If the vibration is intermittent, try to identify the conditions that cause the vibration to occur. Identifying the conditions that cause the vibration to occur can help to narrow down the possible causes. If the vibration is accompanied by a change in the sound of the switch, try to describe the change in sound as accurately as possible. Describing the change in sound can help to identify the source of the vibration. If the vibration is accompanied by a change in the temperature of the switch, try to measure the temperature change as accurately as possible. Measuring the temperature change can help to identify the source of the vibration. Consider using a vibration analyzer to measure the frequency and amplitude of the vibration. A vibration analyzer can help to identify the source of the vibration and determine the severity of the problem. Ensure that the vibration analyzer is properly calibrated and used by a trained operator. A properly calibrated vibration analyzer can provide accurate and reliable measurements. Consider using a stroboscope to visually inspect the moving parts of the switch while it is operating. A stroboscope can help to identify any problems with the moving parts, such as misalignment or imbalance. Ensure that the stroboscope is properly used and that all safety precautions are followed. A stroboscope can be dangerous if not used properly. Consider using a thermal imaging camera to inspect the switch for hot spots. A thermal imaging camera can help to identify loose connections, overloaded components, and other problems that can cause vibration. Ensure that the thermal imaging camera is properly calibrated and used by a trained operator. A properly calibrated thermal imaging camera can provide accurate and reliable measurements. If the vibration is a persistent problem, consider replacing the switch with a new one. Replacing the switch with a new one can provide a long-term solution to the problem. Ensure that the new switch is properly installed and maintained. A properly installed and maintained switch can provide years of reliable service. Remember to consult with a qualified electrical engineer or technician for assistance with troubleshooting and repairing electrical equipment. A qualified professional can provide expert guidance and ensure that all work is performed safely and correctly. Power distribution equipment, like the switchgear in question, can often exhibit audible noise signatures due to the electromagnetic forces acting on the conductors and core steel within the device. These forces are inherent to the operation of the equipment, but their magnitude can be influenced by factors such as load level, harmonic content, and the physical condition of the components. The 60 Hz hum that is noticed corresponds to the fundamental frequency of the alternating current power system. The electromagnetic forces oscillate at twice the line frequency, resulting in a 120 Hz vibration frequency. The presence of harmonics in the current and voltage waveforms can exacerbate the problem, as these harmonics introduce additional frequencies into the electromagnetic forces. These vibrations can be transmitted through the enclosure and amplified by resonant frequencies, resulting in noticeable noise and potentially even structural damage over time. Vibration analysis is a valuable tool for identifying and characterizing these vibrations. It involves measuring the amplitude and frequency of the vibrations at various points on the equipment. The data obtained can be used to identify the source of the vibration and to assess the severity of the problem. Infrared thermography is another useful technique for identifying potential problems. It involves using a thermal imaging camera to detect hot spots in the equipment. Hot spots can indicate loose connections, overloaded components, or other problems that can cause vibration. In addition to addressing the root cause of the vibration, it may also be necessary to implement measures to reduce the transmission of vibration to the surrounding environment. This can be achieved by using vibration isolation mounts, soundproofing materials, or other techniques. It is important to note that vibration and humming in electrical equipment can sometimes be a sign of a more serious underlying problem, such as insulation breakdown or arcing. If these symptoms are observed, it is important to immediately de-energize the equipment and contact a qualified electrician. Arcing, if present in the switchgear, could produce significant audible noise and vibration and can result in rapid degradation of the equipment. It is crucial to investigate the root cause to prevent any catastrophic failures.